Now I'm going to do this on notebook paper because I don't think I might have enough room. You can do it on notebook paper you like as well. You might want to come in here 2 times. Just say you can stand back around. It won't hurt you to listen to it twice. Yes. No, that's fine. If they're with you, it's fine. Come on in, because you're distracting me standing right there. So come on. Pay attention, Noah. All right. Now, guys, on this right here. First of all, which side looks more complicated? Left or right? Left, okay. Left. I'm going to start with that one. Now, I think, are there any fractions in this problem? No. Do you see any squares? No. I can't factor anything out of that, can I? There's no multiplication for foiling. Because you know what foil looks like when 2 parentheses are next to each other. So what's my only option here? I'm going to reduce this, okay? I'm going to reduce this. And the way I do it, secant. How can I rewrite secant? 1 over cosine. Madison, how could I rewrite cotangent x? Cosine over sine. Using the quotient identity. Now watch how I do this. I'm going to start flowing down the paper, okay? Now, what do you think I can do next, Colby? Cancel out the cosine. I'm left with 1 over sine x. Now look, what am I trying to get here? Cosecant. Does that mean the same thing as cosecant? So I write my final answer as cosecant x equals cosecant x, and you just prove to me those are equal. So look how, whatever side I start on, I go under it and I follow straight down the paper, and at the end I put what I get on this side equal to the other. Does that make sense? That's the way I want to see it on yours, okay? Let's look at 2. Alright, I'm going to start with this first goal. It's transform the more complicated side into the simpler side. Which side looks more complicated, left or right? And I'm going to tell you most of these are going to be the left, but know that it could be the right side, okay? Alright. Do I need to find a common denominator at the moment? No. Do I have any squares? No. Do I need to factor this? No, it's kind of almost impact factor form, isn't it? Because you got that outside of the parentheses. Do I need a FOIL? FOIL is when you have 2 binomials. Do I have that? So what I'm going to do? Reduce to sine and cosine. Alright, so sine theta. Okay, what is cotangent equal to in terms of sine and cosine? What's cotangent? Very good. Cosine over sine. Juliet, how about tangent? Okay, very good. Now, when you do that, what emerges? Do you see fractions? So you go back to your toolkit strategies. Should I might find a common denominator now? Yes, because I have fractions in there. Does that make sense? You might have to go into your toolkit more than once, okay? What would be my common denominator of sine and cosine? It has to be both of them, don't it? So watch this, sine theta, I'm going to put a cosine theta here, plus sine theta, cosine theta here. What did I multiply the denominator by here, Jack? What did I multiply the denominator by? It was already sine. What did I multiply by? Cosine. If I multiply the denominator by that, Miss Knight, what am I to multiply the numerator by? So if I multiply this by cosine, now multiply that by cosine. What's cosine times cosine, Alex? Cosine squared. Very good. Mason, what did I multiply this denominator by? sine. So what do I multiply numerator by? Sine. Whoop! What do we see? What do we see in that numerator? What do we see in that numerator? Hold on. Let's just write it. Hold on. I want you to see this. Are we about to go back to our toolkit strategies? Because I see squares, don't I? Cosine squared plus sine squared. Is that one of these? Yes, it is. Okay. What is sine squared plus cosine squared equal to? 1. Even though it's turned around, can I not put a 1 right there? Does that make sense? This over this, I added this plus this. Cosine squared plus sine squared is 1. Remember, what am I working toward? Secant. Baby, what do you think we need to do next? What is it? Yes, thank you, Matthew. Matthew, why can I cancel here? Because if there was a plus in between sine and cosine, could I do that? No, but because it's multiplication, you can. I can cancel that. I'm left with 1 over cosine of theta. Is that equal to secant theta? Don't you love these problems? It's like a little mystery. Goodbye. Alright. So, are there any questions so far? Gary, what you think about this? Don't it make you feel smart? You're already smart, but don't it make you feel smarter?
Sure.
Alright. Let's look at number 3. I'm going to let it marinate after we do this one. Just a second. Let's just keep going. Alright. Number 3. Yes, we see squares and cubes right now. That's a square, sorry. But does that look like any Pythagorean identity right now? No, but you can't do that right now. So no, there's no fractions. How about factor? What did you say? There's a cosine. Do you see that both these terms have a cosine? Factors when you take something out in common, don't you? Alright, so I'm going to take a cosine out. Okay, I had a cosine, I took a cosine out. What do I put in place there? Oh, a 1. Because that's an understood 1 in front of it. Had a cosine, I took a cosine. What does that leave over here? Sine squared. Let's stop right there and let's see if you... Go ahead, Kobe. What were you about to say? Go ahead. Make me proud. Kobe just said, inside this parentheses, that looks like a what identity? I can manipulate this main one right here, moving that cosine over. Moving that sine over. 1 minus sine squared is equal to what? Cosine squared. I can put that in place right here. What's 1 cosine times 2 cosines I'm going to give you? Is that what I wanted? That's my answer. That's my proof. These are your trig proofs for these problems. What you think of this, Holly? It doesn't get much harder than this. Alright. What you thinking, Jackson? What? I like that positivity. Now let's look at number 4. Number 4. Secant theta plus tangent theta equals 1 plus sine theta over cosine theta. You're probably thinking the right side looks more complicated. But what's in the right side? Sine and what? That's pretty basic. You can't break that down anymore, can you? But can you break secant and tangent down?
Yes.
So yeah, that's what we want to do. Do we need to find a common denominator? Would that be a strategy we use here? Do you see any squares or anything? Can I factor anything out? Can I FOIL? My only option is to break down to what? You need to know this list, guys. So when you attack these problems, you need to go, I always say, is there a common denominator? Nope, check, Pythagorean. Know this, and you ask yourself these questions every time. If you keep this into your mind, then these won't be hard, okay? Yes, sir.
But if you make it a common denominator, then it's 1 over cosine theta plus.
Okay, are you still talking about the left side? That's what we're about to do. Hold on just a second. I'm about to get there. All right. Secant theta. How can I rewrite secant, Alan? 1 over cosine theta. Very good. Ivy, how can I write tangent of theta?
Sine theta.
Okay. Now let's look at this. We're adding. Do they already have a common denominator?
Yes.
So all you can do is put 1 plus sine theta over cosine theta. Is that what you wanted? You're done with the problem. You just proved that that's equal. Basically breaking it down, it already had cosine in the denominator. Adding fraction, you need a common denominator. I already had that. And just put 1 plus sine. You cannot combine these because these are not like terms. Well, then you happen to see that happens to match what I wanted, so I'm done with the problem. So some are quick like that.
I simplified it a bit more where I just got rid of the cosine on the O right now.
Yeah, you can't go any. Yeah, you can't go any deeper on that one. Number 5. Now I'm going to go and tell you this, guys. If your neighbor might do it a different way, as long as it's mathematically correct, I will count it. You just can't create some math, okay? Does everybody understand that? So just remember, when you're working with your neighbor. All right. Abigail, which side would you start on this one? The left. I would probably do the left because I see it. Hey, you might do the right. Now, I'm going to also tell you might start one side and not get too far. Sometimes you have to erase and start over. That's okay. Because sometimes it doesn't go the direction you want it to go, okay? Now, I'm going to start with this side. Cosecant squared. How could I write that as a reciprocal? 1 over what? 1 over sine squared. I know that we didn't have that one, but if you had cosecant squared, cosecant is equal to 1 over sine, isn't it? Well, cosecant squared will be 1 over sine. That's okay. Divided by, because that means division. What's the definition of cotangent? But in terms of cosine and sine. Cosine over sine. That's a complex fraction. So what I'm going to do is rewrite it like this so I can work with it. For right now, I want you to work it out until we have a few days, and then by test day I will. That's fine, okay? Because you will make a careless mistake at the moment. When you're dividing fractions, you multiply by the what? Could I cross simplify here? I could take how many signs out? 1. If I take 1 there, it's gone. I take 1, how many's left here? Okay. What's left in this spot right there? 1 times 1 is 1. Sine x times cosine x is sine x cosine x. I don't know why I put it here. I should have put it down here. Now, guys, you got to think. I got down to 1 over sine x cosine x. I'm trying to get it to look like this right here. Is there some way I could make it look from like this to this?
Yes.
I could rewrite this, because what's 1 over sine? 1 over cosine is? Oh, is that what I wanted? You can Mr. explain that again. Okay, hold on. I have 1 over sine x and 1 over cosine x. I could break those fractions apart and put 1 over sine and 1 over cosine. Won't that mean cosecant and secant? That's legal in math, okay? Does that make sense? What you thinking, Mason? Okay. And positivity. Any questions on that? Okay, number 6 is very similar to number 4. We're not going to do that one. Let's turn over to number 7. Ooh, this is a good one. This is a real good one. Alright. What side looks more complicated? Left or right? Which one? Everybody. The left. Okay. Now, do I have any fractions? No, I do not, do I? I have some squares, but right now it doesn't look like a Pythagorean identity, but don't throw it out at the moment, okay? Factoring. I could take a sign out.
You can cancel the cosecant and the
You could do these either two ways. There's two ways you could do this problem, so this is what I'm saying. You could factor sign out, and then when you factor sign out, it's going to give you a common denominator. You're going to get the same thing. Or what you could do is, I love the Pythagorean identity, so I'm not going to mess with that square right now. Could you rewrite this cosecant as 1 over sine? I'm going to do it both ways and show you that you could have done it either way. What happens to these signs right here? So I'm left with 1 minus sine squared theta. Well, could that be manipulated from this first one right here? Couldn't I move that sine squared over? And what would that be equal to? Is that what I wanted?
Yes.
Okay. Now I'm going to do it the other way to show you could do it the other way. If we have factored, but you only have to do it one way, you don't have to do it both ways. That would have been 1 over sine. I got to find a common denominator, don't I? The common denominator would be sine theta. If I multiply this 1 by sine, because there's already sine theta there, if I multiply this by 1, sine theta times sine theta would be what on the numerator? Sine squared theta. I would be left with sine theta, 1 minus sine squared theta over sine theta. What can I do with these sine thetas? You're left with 1 minus sine squared theta, and what does that equal to? Because that's one of the Pythagorean identities. So you could have done it in one of two ways there. Either way would have been fine. Yes?
Could you have added sine squared theta to the other side and solved it?
Oh, good question. No, do not start moving stuff to the other side. You got to pick one side and go from there. There, I'm glad that's always students sometimes try to move stuff. No, you're trying to prove one side is equal to the other, but not moving things over. Great question there. Do not move stuff to the other side. Okay. All right. Let's look at number 8. Okay. Now, what does that one shout out to you and do? This is an example of which strategy? Full. Today, I know I'm doing a lot of talking today, but I'm trying to show you an example of each of them. After today, we slow down, okay? But I want to show you. Do you see why this is an example of full right there? Don't it look like multiplication? So let's full that out. Cosecant times cosecant is? Cosecant times negative cotangent would be negative cosecant theta, cotangent theta, plus cosecant theta, cotangent theta. What happens to those middle terms? Because they're like terms, aren't they? So you're left with cosecant squared minus cotangent theta. Now, ding, ding, ding. What do you see in both of those? Very good. Now go to the original one right here. The original one. I need one to be by, I need cosecant minus cotangent. Well, cosecant's positive. If I brought cotangent over, it would be negative, wouldn't it? What is that equal to then? Is that what I try to prove? And that's my answer. Now, if one thing I do want you to do right now, if you get good at it, if you got to manipulate one of these identities, I want you to go to the side and show me how you did that, okay? Is that a deal? Do you understand it? Until you get good at it, and then probably by test after and say, just do it. You got me? But right now, I want you to show me how you're doing this off to the side. It's not too bad, is it? It's like a puzzle, and that's why I love this. It's like puzzles. Okay? Let's keep going. This is a very easy one, isn't it? Yes. I can rewrite cosecant as 1 over what? What happens with sines? So 1 equals 1. Can you see my son? Okay. We're going to do 10 and 12 and we'll call it a day. Number 11 is a challenge. I couldn't figure that one out. And I did that in 30 minutes. I think it's a typo somewhere on number 11. So we're going to skip 11. Alright, number 10. Do I have any fractions? No. First of all, which side looks more complicated, left or right? Left. Okay, there's no fractions, so I won't use common denominator. I don't see any squares that resemble Pythagorean identity. Can I factor anything? No. Does it look like 4? So what's reduced down to what? Sine and cosine. So cosine x plus sine x. How do I rewrite tangent in terms of sine and cosine? Very good. So now it's going to be cosine x plus sine squared x over cosine. How did you get sine squared? Sine times sine is sine squared. Now, what you see up here now is a fraction. So do I need to go back in my toolkit box and do what? Find a common what? What's your common denominator here? Cosine, so I'm going to put cosine here. If I multiply the denominator by cosine here, do I need to multiply the numerator? What's cosine times cosine? Now, you have to admit, this is better than inverse trig. Now, what you see up here? What do you see up here, that numerator? Cosine squared. Don't you love that? That's like music to my ears. What's cosine squared plus sine squared? 1 over cosine x, which equals what? Is that what I want is secant x? We're going to do number 12 and call it a day. Number 12, do I have any fractions? Do I have any fractions? So do I need to do this first one? Now I see some squares, so I might need to investigate on them. That in parentheses is calling my attention. Secant squared minus 1. Oh, I can manipulate this second one to bring this 1 over. It would be minus 1, wouldn't it? So what can I put in place of that parentheses? Tangent. That's what I'm going to do. Now I'm going to rewrite this in terms of sine and cosine. Cosine squared over sine squared. Tangent sine over cosine squared. Can I cross all these out? What's that equal to? That's your answer. There's your proof. How do you feel on day 1? I just need a hand sit on day 1. Remember, I got 3 more days, 4 more days. Okay. Jesse, what I would suggest is you need to have this at the top of your paper, okay? Top of your paper, okay? And just ask yourself these questions. Does it have a fraction in it?
I'm just confused on number 7 how we're going to the sign order and just make one equal to
Which one, honey? That's the only thing you put. First way or second? Oh, you know that? That's why you cannot do that. It's kind of you change side. That's why you cannot do that. Does that make sense? You can never. You just have to pick a side and start with it. You can because when you put it on you change the whole unit. Does that make sense?
It'll be easier if you're at home Wednesday.
I know, but you had this last year, so it should be. Huh?
It's not clicking at all.
Well, you better try the homework. Don't come in with nothing blank.
I got you, but
I know.
Can I do the homework check?
Mm-hmm. Yeah, let me get that to you. Yes, hon.
I just have a question on what this says.
Oh, your homework is page 3, 4, 1 through 12. Okay, 1 through 12, and they're not. I didn't put many hard. There ain't many hard ones on that. Those should be easy. Mm-hmm. Which one?
On 10. Because that was something to do and then that was.
That's just a dot. It's 1 plus 2 squared.
Okay. On
Which one? What I would do, you could rewrite secant as 1 over cosine squared. So it's going to have sine squared over cosine squared, which is tangent squared. So 1 plus tangent squared equals identity.
I can just take off that.
Gotcha. No, you're fine.
How you doing?
I'm good. You're fine. Sure. Identities.